Hi everyone, and welcome to our video on some exam questions related to energy. Our first exam question states, a student investigated how much energy from the sun was incident on the Earth's surface at her location. She put an insulated pan of water in direct sunlight and measured the time it took for the temperature of the water to increase by 0.6 degrees. The apparatus she used is shown in the figure below. So we have the figure and it shows the apparatus that she used. It says choose the most appropriate resolution for the thermometer used by the student. So if we link back to the question, you can see that the temperature of the water increased by 0.6 degrees. Now that's not a multiple of 1 or 0.5. So the resolution that we're going to use is going to be 0.1 degrees. Okay, that's going to give you 1 mark. It says the energy transferred to the water was 1050 joules. The time taken for the water temperature to increase by 0.6 degrees was 5 minutes. The specific heat capacity of water is 4200 joules per kilogram per degree Celsius. Write down the equation which links energy transferred, power and time. So it's just something you need to know. Power is equal to the energy transferred divided by the time. Okay, and that would get you 1 mark. The next question says calculate the mean power supplied by the sun to the water in the pan. Okay, so we have the equation, we need to calculate the mean power. So we need the energy transferred, which is 1050 joules, and we need the time, which was 5 minutes. Okay, so all we're going to do is 1050 divided by the time, which is going to be in seconds, so we need to do 5 multiplied by 60, giving us 300. So 1050 divided by 300, you can use a calculator, and that would get you 3.5. So the average power is 3.5 watts for 2 marks. Next question, it says calculate the mass of water the student used in her investigation and use the correct equation from the physics equation sheet. So we're given the specific heat capacity here, we're given the change in temperature, and we're given the total energy transferred. So what equation we're going to use? We're going to use a specific heat capacity equation. So we're going to use the thermal energy is equal to the mass multiplied by the specific heat capacity multiplied by the change in temperature. We know that the energy supplied is 1050 joules. So we have 1050 joules. We need to work out the mass. We know that the specific heat capacity is 4200 joules, and we know that the change in temperature is 0.6 degrees. So that's what we're going to do. To get mass by itself, because this is essentially what we want to work out, we're going to divide 4200 multiplied by 0.6 on both sides. So this is what we're going to type into the calculator. So we have 1050, and we're going to divide it by 4200 multiplied by 0.6, and that's going to give you an answer of 5/12. Okay, so the mass is going to be 0.417. So 0.417. Okay, and that would get you 3 marks. Okay, next question. The student's results can only be used as an estimate of the mean power at her location. Give one reason why. So if we link back to the question, why can it only be used as the mean? It's because the solar radiation could be different at different times. That's why we've worked out the mean power output. Okay, so the solar radiation could be different at different times. So the intensity of the solar radiation could be different at different times. Okay, and that would get you 1 mark. Next question. A student investigated the efficiency of a motor using the equipment in figure 1. He used the motor to lift a weight of 2.5 newtons at a height of 2 meters. He measured the speed at which the weight was lifted and calculated the efficiency of the energy transfer. He repeated the experiment to gain 2 sets of data. Give one variable that the student controlled in this investigation. So as you can see, we have the weight here and we have the distance over here. And we're calculating the efficiency of the energy transfer. And the control variables, the distance from the motor and the weight must be the same, and the weight must be the same as well. So what you could have had, the height has to be the same. The height of 2 meters has to be the same. That's something that needs to be kept constant. That would get you 1 mark. Next question, give 2 reasons why taking repeat readings for taking repeat readings in an investigation. So as you can see, he repeated the experiment to gain 2 sets of data. Why do you repeat? It's to find the mean average, to find the mean average, and you can also take it to remove anomalous results. Okay, you could have also said to remove random errors. Okay, and that would get you 2 marks. Next question. Figure 2 shows a graph of the students' results. Give 2 conclusions that can be made from the data in figure 2. So as you can see, one of the most obvious conclusions that can be made is that as the speed increases, the efficiency also increases. So as the speed increases, the efficiency of the motor also increases. Okay? However, that would only be worth 1 mark, and this question is worth 2 marks. What else can be said? Now, efficiency, as you can see, the graph is starting to curve off. It's not going at an increasing rate, it's going at a decreasing rate. Now, what does this tell you? If it's going at a decreasing rate, it's starting to curve off, and efficiency is on the y-axis. That tells you that nothing is 100% efficient. The line is curving off because efficiency is below 100%. Okay, so the next point that you would have to say is the line is curving off because efficiency is below 100%. Okay, and that would get you 2 marks. Next question, give the main way that the motor is likely to waste energy. Now, whenever the motor is on, you will hear noise and it will heat up. So the most likely way that it's going to waste energy is by heating up. Okay, so by heating up. Or you could have said that it's going to waste energy through the thermal energy store. Energy is going to be wasted. Okay, and that's going to give you 1 mark. Okay, when the total power input to the motor was 5 watts, the motor could not lift 2.5 newtons weight. State the efficiency of the motor. So remember that efficiency is the useful power input divided by the total power output. Now it says that it couldn't lift 2.5 newtons of the weight. So if it couldn't lift that much of the weight, how much was the total weight? The total weight was also 2.5 newtons. And if it couldn't lift that 2.5 newtons up, then the efficiency is 0%. And that would get you 1 mark. Next question. The figure below shows a student before and after a bungee jump. The bungee cord has an unstretched length of 20 meters. The mass of the student is 50 kilograms. The gravitational field strength is 9.8 newtons per kg. Write down the equation which links gravitational field strength, gravitational potential energy, height and mass. So nice and easy equation to remember. So we have the gravitational potential energy, and that's equal to the mass multiplied by the gravitational field strength multiplied by the height. Okay, and that would get you 1 mark. Next question. Calculate the change in gravitational potential energy from the position where the student jumps to the point 20 meters below. So at this point we need to calculate the gravitational potential energy. So we know the mass is 50, we know the gravitational field strength is 9.8, and we know that the height is 20 meters. Okay, so all we're going to do is going to substitute into the equation mgh, 50 kilograms multiplied by 9.8 multiplied by the height, which is 20 meters. Okay, so the change in gravitational potential energy, that's all you're going to do. 50 multiplied by 9.8 multiplied by 20. Okay, and that's going to give you an answer of 9,800 joules for 2 marks. Now it says 80% of this change in gravitational potential energy has been transferred to the student's kinetic energy store. How much has the student's kinetic energy store increased after falling 20 meters? So 80% of it has been transferred. So all you do is 80% of 9,800, and that will get you your 1 mark. So find 10%, that's 980, and then 980 multiplied by 8. That's going to give you 7,840 for 1 mark. Next question. Calculate the speed of the student after falling 20 meters. Give your answer to 2 significant figures. So because we're calculating the speed, we're going to use half mv squared, and we know that that's going to be equal to the kinetic energy gained. So it's going to be half. We know that our mass is 50 kilograms. We need to work out our speed, and that's equal to 7,840. Okay, so half of 50, you should just know that it's going to be 25. So 25 v squared is 7,840, and then you can divide by 25. So 7,840 divided by 25, and that's going to give you 313.6, and that's equal to v squared. To get v by itself, you do the opposite, so you square root. So v is equal to the square root of 313.6. Okay, so square root of answer, and that's going to give you 17.708, and so on. It says 2 significant figures, so that's going to be 18 meters per second for for 4 marks. Okay, final question now. At the lowest point in the jump, the energy stored by the stretched bungee is 24.5 kilojoules. The bungee cord behaves like a spring. Calculate the spring constant of the bungee cord. So again, we're going to use this equation now, half ke squared. We know that is equal to the total energy, which is 24.5 kilojoules. Now, the spring constant is what we need to work out, and the extension we already know. If we go back to the image, the extension is from 20 to 55. So 20 to 55 is 35. Okay, so the extension is 35. So half k 35 squared is equal to, remember we need our energy in joules and not kilojoules, so we can just multiply that by 1000. That's going to give us 24,500 joules. Now 35 squared is going to give you 1225, and remember you need to half it, so divided by 2, that's going to give you 612.5 k. Okay, and that's equal to 24,500. So you're going to divide on both sides to get k by itself. Okay, so 24,500 divided by 612.5, and that's going to give you 40. So your answer for the spring constant is 40 newtons per meter, and that would get you 3 marks. And that is it for this video. Thanks for watching. I hope you liked it, and one last thing, please subscribe, hit the like button and the notification bell.